Section 2.4, Problems and Solutions of Nuclear District Heating. Based on the above analysis of the advantages of nuclear district heating is an effective means to achieve green development and efficient operation, and has a good development prospect. However, the progress of nuclear heating with many advantages is very slow, and there are many difficulties in its application in China at present. Through the study of the domestic status quo, this paper discusses the specific problems existing in the field of nuclear district heating in China, and draws lessons from foreign experience, puts forward practical and feasible solutions to promote the clean heating work in China and promote the popularization and application of nuclear district heating. 4.1. Selection of reactor type scheme. In terms of reactor type selection for district heating, the heat sources of nuclear district heating in Eastern European countries are large-scale commercial reactors with mature technology, which have a large heating range, form economies of scale, and adapt to the cold climate and intensive heating demand in Eastern Europe. However, the application of large-scale reactors in regional heating in China is very limited, mainly for two reasons. First, China's nuclear safety regulations require that the radius of the planned restricted area of large-scale nuclear power units should be at least 5,000 m. When nuclear power plants are used for heating urban residents, they should be at least 10 km away from the development boundary of cities and towns with a population of more than 100,000 and at least 25 km away from the development boundary of cities and towns with a population of more than 1 million. Thus, the number of heating residents around large nuclear power plants is limited. Secondly, in terms of the scale of heat sources, the current power of China's main heating units is between 200 MW and 300 MW, and the power of large-scale commercial reactors is about 1,000 MW, which is too large for regional heating capacity. In recent years, the concept of small reactor has been put forward internationally. The small reactor is a 330 MW integrated pressurized water reactor developed by KERI, Korea Atomic Energy Research Institute, together with domestic users and suppliers for power generation, seawater desalination or district heating. Different from the traditional large-scale pressurized water reactor, the small-scale reactor installs the core, steam generator, pressurizer, control element drive mechanism, main coolant pump, and other main components in a steel pressure vessel. This innovative and progressiveness overall arrangement enhances the safety, reliability, performance and operability of small reactors, and has been fully proved in the commercial operation of foreign power reactors. Although small reactors lack the economies of scale of large reactors, due to their system simplification, reactor system modularization, component standardization, factory manufacturing and easy on-site installation, the installation cost of large pipelines and valves is reduced, and their small floor space also reduces the construction cost and improves the economy of the reactor to a certain extent. On the other hand, small-scale reactors have small thermal energy storage and less decay heat after shutdown. Moreover, passive safety systems are widely used, with high safety performance. Theoretically, they can be built around densely populated areas such as large cities. Small-scale reactors are more suitable as heating sources in urban areas. The Modular Small Reactor ACP-100, Modular High-Temperature Gas-Cooled Reactor HTPPM and 200 MW Low-Temperature Heating Reactor currently being developed in China belong to the category of small reactors and have the potential to be applied to urban heating. As for the heating mode, the longest heating period in northern cities of China is only 6 months. If the simple heating mode is adopted, the economic competitiveness is poor, and the domestic thermal power cogeneration mode is more suitable. Therefore, it is relatively reasonable for China's nuclear power district heating to adopt the scheme of small-scale reactor cogeneration with high safety. 4.2. Construction of district heating network. At present, nuclear power plants are mainly used for power production. For safety reasons, their location is far away from residential areas, so they need a long district heating network. China has not yet developed a heating network, but there is a mature heating network in the cold northern region of Europe. Considering the climate, population density, energy price and other factors, the proportion of citizens for district heating increases from south to north, and the heating network is mostly distributed in areas with high population density and low energy availability. The operation mode of heat supply network is similar to that of power grid. A large thermal transmission line is transmitted to the secondary pipeline and finally to the local distribution network at the customer's end. The district heating network sector benefits from improved communication, control and regulatory systems. For example, sensors that detect leaks or hot spots can relay this information to the control room to improve maintenance. However, the construction cost of heat transmission trunk line is high, which will determine the economic feasibility of the project. However, with the rise of energy prices, the demand for heating in the region is also rising. The combination of cogeneration plant and district heating is an efficient heating method, which can keep the heating price of users at a reasonable level. According to the characteristics of heat supply areas in China, the cold regions in the north have a large population and dense urban buildings, which are suitable for the development of central district heating. The heating network can start from small and scattered, and then gradually grow, and connect with each other over time, thus avoiding the need for a large amount of initial investment. 4.3. Operation and coupling of nuclear power plant. The nuclear district heating technology has not yet had mature commercial operation experience in China. The coupling technology between the reactor type itself and the heat supply network is one of the difficulties. The main challenge is to prevent radioactive substances from entering the heat supply network. Referring to the experience of foreign district heating, the nuclear power plant can be coupled to the district heating system by referring to the mode of cogeneration power plant. First, multiple closed loops are set between the primary loop of the reactor core and the end user to prevent the risk of radioactive contamination. Secondly, a specific loop is set to separate the user from the main heat transfer loop. Thirdly, an isolation valve is set on the main transmission circuit to prevent any material exchange between the reactor and the local power distribution network. Finally, ensure that the water pressure in the main transmission circuit is higher than the steam pressure, so as to prevent the secondary steam from entering the heat transmission circuit in case of accidental leakage of the hot water heat exchanger pipe. By taking the above defensive measures, even if the reactor steam generator and water heat exchanger leak at the same time, the reliable operation of the nuclear power district heating system can be ensured. 4.4. Safety of nuclear power plant. Although the safety of nuclear district heating is basically the same as that of nuclear facilities, there are some specific safety problems in the coupling between nuclear power plants and district heating systems. In the cogeneration mode, unlike nuclear power generation, which uses seawater, rivers or cooling towers as cooling, the heat transfer network system also plays a major role in cooling. Any failure, such as pipe rupture or heat exchanger defect, will affect the cooling performance of nuclear components. On the other hand, due to its huge heat capacity, the heat transmission line also provides an alternative radiator for the nuclear power plant. In this sense, the district heating cogeneration facility can even improve the safety level of the nuclear power plant. In addition, small reactors are in the initial stage in China and around the world. Although most of the current small reactor schemes apply the passive concept, simplified system design and mature equipment, and the theoretical core melting probability is very low, the safety still needs to be verified by demonstration projects. At present, Liaoning, Shandong and other provinces in China have begun to build large-scale nuclear power projects, which can be used as the transition of small-scale reactor district heating. Nuclear power plants under construction or to be built in the north can be selected as the pilot of cogeneration, and relevant mature technologies in the world can be used for reference to heat the living quarters in the plant area or small towns around the power station. Through the pilot, the safety of the coupling technology between the nuclear power plant and the thermal pipe network can be verified, and the nuclear engineering experience can be accumulated for the subsequent gradual promotion of the coastal small reactor project. 4.5. Economy of nuclear power plant. According to relevant foreign studies, the total cost of district heating system can be divided into design cost, investment cost and operation cost. Design cost refers to the expenses that must be paid before the construction stage, such as market research, safety analysis, public acceptance survey, etc. The investment cost refers to the construction and installation cost of infrastructure, such as the transformation of the secondary circuit of the power plant, the laying of the heat transmission pipeline, the connection of the distribution network, etc. Operation and maintenance costs refer to the expenses related to the operation and maintenance of the project, such as the salaries of operation and maintenance personnel, maintenance expenses, etc. Different from nuclear power generation, district heating needs to lay a thermal network, so the construction cost of thermal transmission pipeline is a part that needs to be paid attention to in the future, and the economic benefit can be improved by controlling its cost. At the same time, the preliminary planning and design should be connected and coordinated with the built heating pipelines to lay the foundation for the systematic and large-scale development of the municipal heating network and improve social benefits to a certain extent. The nuclear district heating technology has little commercial operation experience in China. At present, there are no relevant regulations and technical regulations. If the technical specifications of nuclear power generation reactor are simply applied, it will have an impact on the economy. Relevant departments can improve the laws, regulations and standard system of nuclear heating reactors through scientific evaluation of small-scale reactor demonstration projects, large-scale reactor cogeneration, large-scale nuclear power generation and other projects. In addition, compared with large reactors, if small reactors are used for district heating, the unit construction cost will rise due to the decline of reactor scale, and the economy will face greater challenges. Therefore, in the early stage of the development of nuclear district heating, it needs the strong support of the state and the government to increase subsidies, so as to make nuclear district heating competitive in the market.